Question number 6, exercise 3.3, topic permutation combination. We have done the first two cases. The third case is C, which is consonants are at even position. Consonants are at even positions. Now see students, when they say consonants are at even position, what does that mean? What was the word that we had? The word was algorithm. Algorithm was the word. Now, as you know, students, there are 3 vowels in this. There are 3 vowels in this, and there are 6 consonants we have. There are 6 consonants. So I will write here, there are 6 consonants in the given word. Along with 3 vowels. Now see students, the total 9, there are total 9 letters. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now what are even positions? See 1, 2, 3, 4, 5, 6, 7, 8, and 9. So what are even positions? The even positions are here. This is an even position. This one, this one, this one. What they are saying that the consonants are at even position. So we have total 4 even positions. I write here. There are 4 even positions. I'm sorry. Students, they have clearly said that consonants are at even position. The consonants are at even position. Now 6 consonants we need to arrange at these 4 places. Now I know what you are thinking. You're thinking that if there are 6 consonants, then how can they be arranged at 4 places? Please understand, student, they haven't said that consonants are at even position only. No. They are saying that consonants are at even position. That is, vowels are not at even position. They haven't said that consonants are at even position only. They haven't said that way. So here there are 6 consonants. How can we arrange 6 consonants at 4 places? Okay. See, the thing is, we know that 6 consonants that we have are L, G, R, T, H, and M. Now what will happen when you will go for the arrangement of 6 consonants at even places? You know, any 4 of these will be arranged, like say L, G, R, T. In a particular arrangement, from 6, you can have any 4. The remaining 2 will definitely go to odd places. So the remaining 2. Now in this case, in this arrangement, what is happening? These are the 4 which are being arranged. So H and M. H can come here, M can come here, and these places will be A, O, I. You understand? So what they are saying is that fulfilled. Consonants are at even position. Are the consonants at even position? You can check. Even position, consonant, 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 consonant. Now here some students are confused. They will say that why the consonant is at odd position. Okay, please understand. They haven't said that consonants are at even position only. They haven't said that. It means consonants are at even position. They can even be at odd position. Okay, but they are saying consonants are at even position. That definitely mean that vowels are not at even position. Okay, the vowels will always be at odd position. You can check. The vowels will always be at odd position. So see students, what I will do. First of all, I will arrange these 6 consonants at 4 even position. And that can be done in 6p4 different ways. Okay, that can be done in 6p4 different ways. So I will write here, I will write these 6 consonants. I'll write these 6 consonants can be arranged in 4 even positions, in 4 even positions in 6p4 different ways. Okay, see there are 6 consonants and 4 positions. It is going to be 6p4. Okay, it is going to be 6p4. Now look at this. What are you now left with? This is not the end. Please understand, it is not the end. Why? Because these places are still blank. You know, you have to have letters here also. So what you will say is, now these five odd places are there where we need to arrange 5 letters. Which 5 letters? Try to get this here. The 5 letters will be 3 vowels and 2 leftover consonants. 2 leftover consonants. Remember, there were 6 consonants, of which you could arrange only 4. So 2 consonants are still in pipeline. You understand? So I will write the 5 odd places. I'll write here the 5 other letters, or I will write it like this. I'll write the 3 vowels and 2 left over consonants or remaining consonants that is 5 letters can be arranged in remaining 5 places in 5p5, that is 5 factorial ways. Okay, 5 factorial is 120 ways. So what will be the total number of arrangements, students? See, 6p4 and 5 factorial, that is 120 ways. So I will write, therefore the total number of required arrangements equals to what we have here, 6p4 into 120. 6p4 into 120. See, what is 6p4 equals to? 6p4 is 6 factorial upon 6 minus 4 factorial, that is 6 factorial upon 2 factorial. Okay. Now, I'll write 6 factorial as 6 into 5 into 4 into 3 into 2 factorial divided by 2 factorial. This is gone. So how much is that? This is 30 into 12, 360. Okay, this is 6p4. Students, I'll give you a shortcut for writing 6p4. Remember, 6p4 is 6p4. How will you write? In order to write 6p4, you will start with 6. See, this is the idea. In order to write 6p4, you will start from 6 and then write 4 numbers in reducing order, decreasing order, descending order. See, 6p4. So I'll start with 6. So 1, 2, 3, 4. Why 4? Because 6p4. And see, anyways, I had got the same. I had got the same thing. So we will use this technique for fast calculation of NPR. So 6p4 will be 6 into 5 into 4 into 3 into 120. That is 360 into 120. Now 36 into 12. This is 4320. Okay, tell me students, have you all followed it? Any doubt to anybody in this?
No.
See students, now the last one is they're saying that O is the first and T is the last letter. Total how many letters are there? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And don't forget what you have to do. The given word was algorithm. Algorithm. They're saying that if this given word algorithm is arranged at these 9 places, how many different arrangements of the letters of the word algorithm we will get if the arrangement always has to begin with O. The beginning, it has to be O. Always the beginning has to be O and the end has to be T. So understand students, the required arrangement, whatever arrangement you have, it should have O in the beginning and T at the last, T at the end. Got it? So O and T are gone. Please understand, you have to arrange all the 9 letters at 9 places. You see this, you have to arrange these 9 letters at 9 places, of which you understand that O is now used up. Why? Because you have already written O at the first place. Same is the case with T. T is also used up. So students, when O and T are used up, what are you left with now? You are now left with 7 letters. You are left with 7 letters. 1, 2, 3, 4, 5, 6, 7. And how many places are there? There are 7 places. So you know, student, that these 7 letters can be arranged. These 7 letters can be arranged in 7 places. These 7 letters can be arranged in 7 places in 77, that is 7 factorial ways. Okay, it can be arranged in 7p7, that is 7 factorial ways. Tell me all, have you followed it? Tell me.
Yes, sir.
So O and T, see, O has to be always in the beginning, which can be done in one way. It can be done in one way. T can be arranged at the end in one way. The remaining 7 letters can be arranged in these 7 places in 7p7, that is 7 factorial ways. It can be done in 7 factorial ways. So here I'll write, see how do I write the answer? The answer which I write now, I'll write the, I'll write here, the letter O and T can be, O and T can be arranged at first and last place, first and last place in one way each, in one way each. I'll write the remaining 7 letters, the remaining 7 letters can be arranged in remaining 7 places in, see there are 7 letters and 7 places, so they can be arranged in 7p7, in 7p7, that is 7 factorial different ways, 7 factorial different ways. Okay, now see here, so the first thing, like you arranged O, see you arranged O and T in one way each, and then you arrange the 7 letters in 7 positions in 7 factorial ways. So the total number of arrangements will be, you have to multiply this one way each with 7 factorial. Why multiply? Very simple, because it is the word and coming in between. See, you have to arrange O, and you have to arrange T, and you have to arrange the 7 letters at 7 positions. So because of and, so you can always say by fundamental principle of, by fundamental principle of counting, by fundamental principle of counting, by fundamental principle of counting, total number of required arrangements is equal to 1 into 1, one way for O, one way for T, into 7 factorial. Okay, that is equal to 5040 ways. There are 5040 types of arrangements for the required question. See, question number 7 from the same exercise. It says in a group photograph, 6 teachers are in first row. So in first row, you have 6 teachers. Okay, so this is say first row, and you have 6 teachers in first row. Okay, so 6 teachers are in first row. T1, T2, T3, T4, T5, and T6. You must be thinking that why this place, why this? Okay, wait, you will understand. So, like there are 6 teachers in the first row. There are 6 teachers in the first row. They say, and 18 students are in the second row. 18 students are in the second row. So in the second row, there are 18 students. So this is first row. Down here, first row. This is first row you also. And this is second row. Okay. And in the second row, how many students are there? There are 18 students, they say. There are 12 boys and 6 girls among the students. 12 boys are there. Okay, in this 18 students, there are 12 boys and 6 girls are there. 6 girls. 6 girls. Further, they say if the middle position is reserved for the principal, and if no two girls are together, find the number of arrangements. Now, students, they are saying that middle position is for the principal. So definitely principal is going to sit amongst the teacher. The principal will sit amongst the teacher. So this is for principal, the middle position. That is 3, 3 on the left of principal, 3 on the right of principal. And then 18 students are there, 18 of which 12 are boys, right? So 12 boys and 3 girls and 3 girls. Got that? So how would you see? Definitely all boys. So B1 like boy, boy you have B1, B2, B3, B4, B5, B6, B7, B8, B9, B10, B11, B12. Okay, these are say 12 boys we have. See students, I'm solving the problem. Whichever problem I solve in big, I solve in a detailed way. I solve it, you know. Uh, but as such, you know, I solve it in a detailed way because I explain it in detail. But once you have understood the concept, you can definitely solve these problems faster. See, goal 1, goal 2, and goal 3. Okay, there are 6 goals. So goal 3, and then you may have few more goals on the other side. Say you may have few goals on the other side also. Yes. Say you have goal 4, goal 5, and goal 6. Got it? So this is a kind of arrangement for a photograph. Okay. In school, there is a group photograph, and this is how the kids are supposed to be sitting along with the teacher and principal. But you know, students, that this arrangement which you see right now on the screen is not the correct arrangement. Why? Because in the question they have said that yes, the 6 teachers are in the first row. Very good. So 6 teachers are in the first row. This is done. They say that the principal is in the middle. Very good. They're saying that 11 students are in the second row. Very well done. That is also fulfilled. But a big condition which they are saying that no two goals are together. You know, they're saying no two goals are together. What does it mean? Very simple. Students, try to understand. You cannot have G1, G2 beside each other, G2, G3. This is not allowed. It is not allowed. So how should these goals be placed? See, the required arrangement could be fulfilled if you are placing these if you are placing these 6 goals in such a way that no two goals are together. It means suppose I write G I ask goal 1 to be here between B1 B2. This is G2 G3 G4 G5 G6 and G5. You understand? So now you can understand that these six goals, between them we have got at least one boy. Between two goals, there is at least one boy that we have, and because of which no two goals are together. So this is one kind of arrangement. See, there can be plenty such arrangements. Try to understand. There can be plenty such arrangements. This is one such arrangement which I am showing it to you for explanation. So once again, I will read the complete question and then I will start answering the question. It says, in a group photograph, 6 teachers are in the first row and 18 students are in the second row. There are 12 boys and 6 girls amongst the students. If the middle position is reserved for the principal and if no two girls are together, find the number of arrangement. If no two girls are together, find the number of arrangements. Okay, so here I will write, if the no two girls are together, find the number of arrangements. I hope you have followed this. So I'll write here, there are 6 teachers, okay, in the first row, along with the principal sitting in the middle. The principal sitting in the middle. Now understand, students, that I have 6 teachers and principal in the middle. Now understand that principal can be arranged in one single way. Okay, there is one principal and one position in the middle. So principal can be arranged in one single way. Then it comes to the teacher. You know, 6 teachers and 6 positions are there. You understand? 6 teachers will be arranged. You remember in last lecture I taught you, when you have to arrange the given number of objects, taking all of them, you can say that they are arranged amongst themselves. You can say that they are arranged amongst themselves. So I will say here, 6 teachers can be arranged amongst themselves in 6p6, that is 6 factorial ways. Remember, students, these are all different teachers. So you will have, this is one arrangement where you have T1, T2, T3 principal, T4, T5, T6. It can be T1, T2, T3 principal, T4, T6, T5, and you understand what I'm talking. So I write here, the principal can be arranged in one way. Okay, it can be arranged in one way. Now I'll go for the arrangement of teachers. I will write the 6 teachers can be arranged the principal in the middle. I should have written in the middle. The principal in the middle, okay, can be arranged in one way. Then the 6 teachers can be arranged amongst themselves in 6p6. The 6 teachers can be arranged amongst themselves in 6p6, that is 6 factorial, that is that is 6 factorial different ways. That is 6 factorial different ways. So please copy this much, because now I will go for the arrangement of students. Now we have the second row. Students, you know that there are total 12 boys and 6 girls. We need to arrange. See, our job is not done yet. Please understand, the job is not done yet. You have arranged only principal and teachers. You still have to arrange the children, 12 students, 12 boys and 6 girls. So what I do, I need to arrange them in such a way that no two girls are together. If you remember, in last lecture, we solved a problem where no two vowels were together, no two vowels together. What did you do in that case? For the word algorithm, you had to arrange the letters of the word algorithm in such a way that no two vowels were together. For that, what you did was you first arranged all the consonants, and then beside each consonant you had two blank places. Okay, so the same thing we are going to do here. I will write, see, 12 boys. So B1, B1, B2, B3, B4, B5, B6, B7, B8, B9, B10, B11, B12. Okay. I will first arrange these boys amongst themselves. So I'll write here 12 boys. 12 boys can be arranged amongst themselves in 12p12, that is 12 factorial different ways. 12 factorial different ways. Now, see here. You have got, beside these 12 boys, total 13 blank places. You can count them. There will be total 13 blank places. You can count. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13. So the remaining 6 girls, remember, the 6 girls which you have, okay, G1, G2, G3, G4, G5, and G6. If these 6 girls are arranged in these 13 places, no two girls will be together. No two girls will be together. So that is what I'm going to do now. So see, how do I write? I'll write here. I'll write here beside each boy there are two blank places. Two blank places. That is, beside 12 boys, there will be 13 blank places. If the six girls are arranged at any six of these 13 blank places, 13 blank places, then no two girls, no two girls will be together. No two girls will be together. I'll write here. This can be done in 13p6 different ways. Now the idea here is, now the thing is, are we done? Can we take a photograph? Can we now take a photograph? The answer is yes. See, it is all done. Why? Because we have arranged the principal, the teacher, the boys, the girls. Yes. So what will be the total number of arrangements? See, we will have to multiply. Yes. Okay, because see, we arrange the principal and the teacher and the boys and the girls. You see this? So since there is word and being used, we'll have to multiply these to get the final number by fundamental principle of counting. So I'll write here, therefore, by fundamental principle of counting, the total number of required arrangements will be, the total number of required arrangements will be 1 principal into 6 factorial teachers into 12 factorial boys into 13p6 different ways. Okay. Now I will simplify this. See here. Now you know if one is multiplied, you get the same answer. So in the next place, I'll write that is. See, let me write 13p6 first. So 13p6 is 13 into, see, I'll write 13p6 as 13 into 12 into 11 into 10 into 9 into 8. See, this is 13p6. You begin with 13 and you go in descending order 6 numbers, right? 13p6. Now I've written this, you know, 1 is not required to be written. Then I write 6 factorial into 6 factorial into 12 factorial. Okay. Now here, students, see, I wrote this, which is this one. Then I wrote this, which is here. Then I wrote this. Now I do a small modification here. You know what? Let me multiply 7 here. After 8, I'm multiplying 7. So if I'm multiplying 7, I'll definitely have to divide by 7. I will definitely have to divide by 7. Now you are thinking that why did I multiply by 7? See, now I'll tell you. If you now start from 13 factorial, if you now start, I'm sorry, if you now start from 13, so see what you have. 13 into 12 into 11 into 6 into 9 into 8 into 7 into 6 factorial. So this is total 13 factorial. You see this from here to here. So your final answer now will be, so see, I'll write the final answer in the next step on the next page. So I write here 13 into 12 into 11 into 10 into 9 into 8 into 7 into 6 factorial into 12 factorial, the whole divided by 7, the whole divided by 7. So now this gives you 13 factorial. Okay. So you have 13 factorial into 12 factorial upon 7. This is answer. Okay. Do not attempt to write the numbers and multiply, please. That is going to be very big otherwise. I hope you all followed it. Okay, so students, at this junction, at this point, I would like to say that the kind of problems we have done, it leads to two different, very important methods. And those methods are, see, one method is known as gap method. One method is known as gap method. And the other method is tie method. Now, what is gap method? Whenever you come across any question where they are saying, like here they said, no two girls are together, you are applying gap method. You are applying gap method. You saw, what did I do? What did I do? I first arranged the boys. And then beside the boys, there were gaps. See, a gap, a gap, a gap. You see this? These are all gaps. So, and then beside 12 boys, there were 13 gaps. And in those 13 gaps, we arranged the 6 girls. Likewise, in the problem where we had the problem where we wanted, if they had said in the same question, say if they had said that all girls are together, if they had said all girls are together, then what would we have done? If all girls are together, then we will go for tie method. That is we will get all the girls, all the 6 girls we will have in one unit. Okay, we will have the 6 girls as a single unit. As if they are tied together. As if they are tied. They are all tied together. We will have these 6 girls tied together. Okay. We will have these 6 girls together, and now these 6 girls together, they make one single unit. This is known as tie method. And then the 12 boys we have, those 12 boys, that is B1, B2, B3, B1, B2, B3, B4, B5, B6, B7, B8, B9, B10, B11, B12. These 12 boys will be treated as 12 units. So what will happen? 12 units of boys and 1 unit of girl. Total 13 units will be arranged amongst themselves, which will get me 13p13, that is 13 factorial ways. So this is the way we would have done had they asked us in the question that all girls are supposed to be together, but they haven't asked that way. That's why we are going for the gap method. The gap method is where they say no two girls are together, and the tie method is they say all the girls are together. If you remember, we had gone the same way in the problem of algorithm where they had said that all the vowels are supposed to be together. And we had gone for tie method when they said all the vowels are supposed to be together. And we had gone for gap method when they had said that no two vowels are together. So gap method and tie method you should understand. Friends, here we have a fantastic question on your screen. See, the question is find the number of ways so that letters of the word history can be arranged as A, Y and T are together. Y is next to T. There is no restriction in the arrangement of the letters of the word history. The arrangement begins and ends with the arrangements begin and end with a vowel. The arrangements end in ST, that is letter S and T will come always at the end. And F is begin with S and end with T. So here I will start with my answer and see in the answer how do I begin. I will write there are 7 letters, 1 2 3 4 5 6 7 7 letters in the word history. Okay, now in these 7 letters, how many vowels we have? We have 2 vowels, I and O. Okay, there are 2 vowels. Okay, I, O. There are 5 consonants. There are 5 consonants. Okay, now I go for answering the first one. The first one is Y and T are together. Now see students, I just told you that we have 2 such very important methods, that is gap method and tie method. So here we are going to use the tie method. See what I will write. I will write here, we will make one unit for the letters Y and T. Okay, so 1 unit for the letters Y and T. This is 1 unit. Okay, I will tie them together. Now I'll say for remaining 5 letters, we will make 5 units. For remaining 5 letters, we will make 5 units. So 1 2 3 4 5 and 6. So you can understand, here you have H, you have S, you have T, you have R, you have Y, you have, I'm sorry. You do not have T here. You have H, S, I, you have O, you have R, and you have Y. I'm sorry, Y is also not there. Yes, I have already made the 5 units. So for remaining 5 letters, we will make 5 units. So here 1 2 3 4 5 5 units. So YT as 1 unit, you can check Y and T as 1 unit, and then HSIOR as 5 units. So now I will arrange these 6 units amongst themselves. And when it is done, what will happen? Y and T will always be together. This can be done in 6p6, that's 6 factorial different ways. So I will write here, these 6 units can be arranged amongst themselves in 6p6 equals to 6 factorial different ways. Different. Now the thing is it done? Is it over? Not yet. Why? Because see students, this yt will go, yt can come anywhere, when you will have that 6p6, that is 6 factorial arrangement. But it will always be in the form yt, that is, you will always have y before t, or you will always have t next to y. But you should understand that they have said that y and t are together. That is, you can have yt, you can have ty. You understand? Even these two can be arranged amongst themselves, and that is in 2p2 2 factorial ways. So I will write here y and t, y, the letters y and t can also be arranged amongst themselves, in 2p2, that is equal to 2 factorial ways. Now I write, therefore, the total number of, that is by fundamental principle of counting, therefore the total number of required arrangements equals to 6 factorial into 2 factorial, that is 720 into 2, that is 1440 ways. This is the answer for the first one. I hope you all follow. Now we have this B where it says y is next to t. Now remember students, this is once again the time method. Why? Because they are saying in the arrangement of the letters of the word history that y is next to t. Now what is meaning of y next to t? Is it going to be this way? No, this is t next to y. When you say y next to t, in all the arrangements, it's gonna be this way. See, y next to t, it's gonna be this way. You will tie the letters t and y, and you will make sure that y is next to t. And what about the other letters? The other letters like H, I, S, O, and R. These 5 letters are in 5 different units. These 5 letters are 5 units. So you have total how many units? You have total 6 units once again. Now the question here you can ask me that why this T and Y are tied? Because see, the case was that Y is next to T. Y is next to T. So in the arrangement, you can have an arrangement like this, or you can have an arrangement CH, then TY, then ISOR. See, you can have an arrangement like this. See again, Y is next to T. You see this? Y is next to T. You can have an arrangement like HISTY. You see this? Again, Y is next to T. So all such arrangements they are talking about. See, you cannot have like this. Try to get this. You cannot have like you cannot have like IHS and then TORY. You cannot have like this. Why? Because here Y is not next to T, Y is next to R. They're saying Y should be next to T. That is, they have to be together. But Y is always next to T. Moreover, you cannot have them together at the same time. You can't have like this SHI and then YTOR. This is also not done. This was not done. This is also not done. Why? Because you cannot have, you will say that y and t are together. Okay, they are together, but then you see that y is before t. They have clearly said that y is next to t. Y is next to t. So what we will do, see students, I hope you all must have understood that in this case, we are going to do exactly what we did in the previous case. But in the previous case, what we did was, see, first we will do exactly what we did there. We will say that we will make one unit. We will say that we will make one unit for the letters y and t, and then we will write it as this way. We will write ty. We will write ty because y is next to t. We will write ty, and then we will say that this one unit along with these 5 units will make total 6 units, and these 6 units can be arranged among themselves in 6p6, that is 6 factorial ways. 6p6, that is 6 factorial ways. And then what we did there, in the earlier case, we will not do it. Why? Because we don't want this ty to be arranged amongst themselves. We don't want these two letters to be arranged amongst themselves. No, we want it always in the form ty. We want it always in the form ty. So the final answer, you understand that 5 here and 1 unit here, so total 6 factorial, and then 6 factorial different ways. The answer is, that is equal to 720 is the answer. I hope you all followed this. I hope you all followed. So you will write this answer, all of you will write this answer on your own. Okay, you will write the answer for B on your own. Now let's go for the C. Look at the C. What does the C say? The C is, there is no restriction. Okay. Now students, if there is no restriction, it means these 7 letters of the word history, any letter can go at any place. Any letter can go at any place. Now you understand, if that is the case, like there is no restriction, then the 7 letters can be arranged amongst themselves. The seven letters of the word history can be arranged amongst themselves in 7p7, that is 7 factorial ways. So the answer for this will be 7 factorial different ways. I hope you followed this also, and you will write the answer for C on your own. Now I go for D. Look at that D. The D is in the arrangements. The arrangements begin and end with vowel. Begin and end with vowel. So how many vowels do we have? First of all, see, we have 2 vowels, I and O. Okay. So here I will write the answer for D. I will write the answer for D. Okay, the answer for C was 7 factorial. The answer for C is 7p7, that is equal to 7 factorial. I will do this B and C you are doing on your own. I am now solving D. What is D? The D says that the arrangements begin and end with vowels. Okay, so let's do it. Arrangements begin and end with vowel. The arrangements begin and end with vowel. So see, total there are 7 letters. 1, 2, 3, 4, 5, 6, and 7. There are 2 vowels. The vowels are I and O. So you can see here, this is first position, this is 7th position. Okay, 1, 2, 3, 4, 5, 6, 7. So see, we have 2 vowels, and we have 2 positions. You see this? We have 2 vowels and we have 2 positions. So it has been said that the arrangements begin with and end with vowel. So the 2 vowels can be arranged at these 2 positions in 2p2, that is 2 factorial different ways. You got this? This I and O. I and O can be arranged in these two places in how many different ways? They can be arranged in 2p2, that is 2 factorial different ways. So I will write here. The two vowels can be arranged in two places, that is in the beginning and the ending in 2p2 equals to 2 factorial ways. After this, the remaining 5 consonants. Okay, and how many places are left? And how many places are left? 5 places are left in between. I will write the remaining 5 consonants. The remaining 5 consonants can be arranged in 5 places in 5p5, that is equal to 5 factorial different ways. So what will be the total answer? So you will have, to multiply these two. Why multiply? You understand? Because you need to see, you needed to arrange the vowels and the consonants. The vowels at these two places and the consonants and the word coming. So multiply the vowels and the consonants. So here I will write, I'll write here, see this and this will be multiplied. I'll write here, therefore, by fundamental principle of counting, the total number of required arrangements equals to how many? 2 factorial into 5 factorial, that is 2 into 120, that is equal to 240. Okay, so this is done. You will all solve. See, I have done this also. You will solve E on your own and you will solve F also on your own. Okay, very simple. The arrangement should end in ST. Now see, all the arrangements should have ST at the end. Now you can understand, if ST, you always want ST. So S and T can be arranged in one way. S and T can be arranged in one way, and the remaining you know. So that is also a homework. And then it should begin with S and end with T. Once again, if the beginning is S, that can be done in one way. If the beginning is S, then it can be done in one way. If the ending is T, it can be done in one way, and the rest 5 in 5 factorial different ways. Okay, so this is the answer. This is 2 problems you will solve on your own, and there are few questions which you have to try on your own. See, you will try question number 16 and question number 17 on your own. 16 and 17 you will solve. 16 and 17 are for practice from the exercise 3.3. Thank you.